Hello everyone. Now we will see the implementation part of pre-order, in-order and post-order traversal. So first of all, let me introduce you to the notations which we are going to use in our code. So this is struct node. Actually we are making a structure, that is node, in which we are having a variable, a character variable, that is char data. Data is the name of variable, and we are having two self-referential pointers. So it is like this, in which there are two pointers, that is it is left and it is right and it is data, and it will store the value as character. Okay, now let me show you the code for Inorder. So void Inorder struct node asterisk t. So what we did is we make a non-return type function for Inorder, in which we are having struct node asterisk t. That is, whenever we will call this function, we will pass the root to this function. Now in the next line, what it is, if t, that is whenever t is not equals to null, we use this convention. It is same like if t not equals to null. So these both are same. So whenever t is not equals to null, we will enter in this in the body of this if condition. So if you remember in Inorder, what was the syntax of Inorder traversal was, first of all we write the left subtree, then root, then right subtree. So this is, we are going to go to the left subtree, and then we are printing the data, and then we are going to the right subtree. Okay, so what we did is, in these two we are actually using the recursion. We are calling a function by we are calling the Inorder function in Inorder function, that is known as recursion. So now let's see the dry run of this program. So let us suppose this is the tree A, B, C, D, E, and we are going to find the Inorder of this tree by the help of this program. So let us suppose this is the instruction 1, this is 2, and this is 3. So as I have already told you, that whenever we are going to call this function, we are going to call this function with the root. So whenever we are going to call this function, we will call this with A. So whether, first of all, it will check whether this is null or not. So this is not null, then it will enter in the body of if condition. So and then it will execute the first instruction. The first instruction is again call this Inorder function with left of it. So we have executed the first instruction of this A. So now we have gone, now we are at this. So let us 1, 2, 3. So B is not having any left children. So first of all, it will check whether it is null or not. So it is not null, then it will enter in the body of if. So first of all, it will execute Inorder with the left of B, but B is not having any left child. So in the place of left child, it is having the address as null. So it will simply not enter in the body of if. It will simply get returned whenever we call the Inorder function with the left of it, because it is having null. So its first instruction is get executed. Now it will simply execute its second instruction, that is printf %t data. So the data of t is B. So it will print B. Now it will go to the third instruction. The third instruction is Inorder, call the Inorder function again with t of right. So all the three instructions of V is now executed. So now we have currently on the node D. So now we will also execute the three instructions on the node D. So first of all we will check whether if D it is null or not. So yes, it is not null, then we will enter in the body of if. So what is first instruction? It is in order to the left, but it is not having any left or right child. So in first instruction it will simply return. The second instruction it will print the data, so it is D. And in the third instruction is in order T to the right, but it is not having any right child also. So all the three instruction is now executed of D. So now we will go back, we will check all the three instruction of this is executed. Yes, all the instruction of all the three instruction of B is executed. Yes. Now let's go to the root, that is A. A is having only one instruction is executed. So now we will execute its second instruction. The second instruction is printf %t t to the data. So what is the data of this? A. So now the second instruction is also executed of the A. Now what is the third instruction? The third instruction is we will call the inorder function again with its right child. So all the three instruction is now executed of A, and we are currently at this node. Okay, 1 2 3. Okay, so what is its first instruction? First instruction is first of all it will check whether it is null or not. Then the first instruction is and call the inorder function again with t of left. Now C is having a left child, that is E. So the first instruction is executed. Now we are at E. 1 2 3. So it will firstly check whether it is null or not, and now E is not having any left child, so it will simply return whenever it get called by its left address. So now its second instruction is print the data, that is E. So now second instruction of the E is also executed. Now the third instruction is go call the inorder function with the right of E, but E is not having any right child, so E is having null as the address of right. So it will simply return. So now we have completed all the instructions of E. Now we will go back to the C. So we previously we have completed first instruction. Now we are about to complete second instruction. What is second instruction? Print the data. The data is C. Okay. So second instruction is completed. Now what is the third instruction? Call the inorder function with the right child of this, but C is not having any right child, so it will simply return. So this, if we see this is the in order of this tree. Now we can also check this whether this is right or wrong with the method that I have told you in previous video. So let's check it. So first of all what we will do is we will make some dummy nodes. Okay. So we will start traversing from A. So if you remember in order what I have told you, that whenever we will reach the node for the second time, then we will print it. So reaching A for the first time, don't do anything. B for the first time, B for the second time, so print B. Now reaching D for the first time, now D for the second time, so print D. Now reaching A to the second time, because first time I have visited the A here, now we are visiting A here, this is the second time, so let's print A. Now we are visiting C for the first time, don't do anything. E for the first time, don't do anything. Now E for the second time, so let's print it. Now E for the third time, now C for the second time. First time we have visited C here, now we are visiting C for the second time, so let's printed. So yeah, so you can check these both are same, so our program is right. Now we can use this program for the for the pre-order and post-order also with the certain modifications. So let me tell you that modifications. All the program you can change the name of the function by post-order or pre-order, and all the program will remain same, but what will be the modification we will do is actually we will rearrange them in any another order. So first of all, let's talk about the pre-order. What was the syntax of pre-order? First of all, print the first of all root, then left subchild, then right subchild. So we will arrange that in these instructions in the order 2, 1 and 3. Yeah. So in pre-order, first of all we will print the root, then we will go to the left child, then we will go to the right child. Now let's see for the post order. What was the syntax of post order? Left subtree, right subtree, then root. So what we will do is we will arrange the instructions like 3 and 2. Firstly we will go to the left, then we will go to the right, and then we will print the root. Okay, so it was the program of Inorder, Preorder and Postorder. I hope you all got this. So thank you very much for watching my video.